Go again. Actually, guys, I reviewed some theoretical aspects and basic foundations of chemical separation processes. Okay, and then I found out that it's very difficult to go to the problem solving if you will not understand the basic concepts on the phase changes, okay, and the phase diagrams like that. And you have to understand also the overall material balance, the energy balances, okay, something like that, and the different kinds of phase points. You know phase points? So there's a lot, right? So I have to discuss that first. And after this, I'll be able also to discuss the theoretical aspects of distillation. Okay, but first and foremost, okay, I need to mention again the some of the physical of chemical separation processes, guys. Okay, at this moment, very late at night, I cannot sleep. Oh my God, I really want to vlog something like that, and there's a problem with my laptop with the connection of the internet cable. So really, it took me a very long time to connect. Something like that. There's a problem, and I used my mobile data. Okay, okay, guys. Uh, Distillation. Okay, we have that. We'll try to discuss that first. We have crystallization. Okay, filtration, chromatography, extraction, absorption, something like that. Evaporation, condensation, sublimation, uh, what is called this one? Deposition, the reverse of sublimation. Actually, deposition is also called desublimation, the reverse of sublimation, something like that. And we have also the drying, okay, the flotation, the screening, the sedimentation. Did I mention filtration already? Okay, filtration, something like that, and a whole lot more. Okay, before going further, we need to understand the terms insoluble, soluble. So what do we mean by insoluble? So of course, it will not dissolve if you try to combine that with another liquid. For example, there's a liquid A. If you mix that in liquid B, it will never dissolve. So it talks about solubility when you talk about soluble or insoluble. Okay? Insoluble will never dissolve to another substance. Okay, when you add that substance to another substance. Substance meaning it could be either liquid, solid, or gas. Okay? Not limited to liquid. And then we have the insoluble will never be dissolved, and then the soluble will be dissolved through solubility. Okay, something like that. Immiscible and miscible. Miscible and immiscible is not, it's not the same with insoluble and soluble, because immiscible it refers only to the layer of the phase, meaning to say mixture. No, mixed, not necessarily the molecules will be distributed to another substance. Okay, if I say ethanol is immiscible to liquid, okay, immiscible meaning they cannot be mixed. Okay, but that not necessarily mean the molecules will be dissolved. You get the point? Because it's another thing when you say soluble, it will be dissolved the molecules, but not referring to the molecules, only the layer. Okay, the positioning of the two substances, it's in the up and then the lower, just like oil and water, the layer. Okay, so that's immiscibility. So immiscible is referring to it cannot be, it cannot be mixed. Okay, the layers will be separate. The other will go up, the other will go down. So it depends on the which is more dense and less dense. Talking about the density of immiscibility, ha. Immiscibility and immiscible and miscible refers to the density. Insoluble or soluble refers to the solubility. Okay, even if you don't know, if you don't watch that one, when you mix sodium chloride to water, you cannot distinguish the layer. So it will just dissolve, so it's soluble. But it's another thing with miscible and immiscible. You can check only the layer, the positioning of two substances when you mix that two, something like that, because it refers on the density. Okay? And another thing also, we need to understand the hydrophobic and the hydrophilic. Okay, the hydrophobic, uh, it will never combine, or it will have no affinity to water. That's hydrophobic substances. But if it is having an affinity with water, ability to combine with water, so that is hydrophilic. Okay, substances that will readily combine to, to water. There's a lot. Okay, mostly inorganic. Okay, but these fats, fats are insoluble, immiscible, and this is hydrophobic substance. Okay, this will not be this will not be dissolved with water. Okay, like that, these fats. Okay, and then after that, we need to understand also the phase changes, because this physical and chemical separation processes involves the phase changes. For example, let's go first with the basic. Okay, we need starts liquid and gas first. Okay, a change from liquid to gas or vapor, that is evaporation or vaporization. Number one. The reverse will be the condensation, a change from gas or vapor to liquid. Okay, we have two na. And then we need to consider na the solid to liquid. A change from solid to liquid, that is fusion or melting. So we have fusion point and melting point, something like that. And the reverse to that, a change from solid to liquid and liquid to solid. So there's also a reverse for that. That is freezing. Okay, we have now four. Okay, liquid to solid, freezing, for example, the ice. Okay, it reverse, right? Freezing. Number five, the solid to gas. Okay, when the solid change to gas, okay, that is sublimation. Okay, and the reverse for that, that is deposition, deposition, or what we call a desublimation. So there are at least 6 phase changes. Of course, somewhere along the way, in that different physical and chemical separation processes that I mentioned a while ago, this will really involve every time either of the 6 phase changes. For example, filtration, it involves one of the phase changes or 2 or 3 of the phase changes I mentioned just now. So we need to understand the phase changes also. Okay, and now also we need to troubleshoot or memorize the standard heat of vaporization, the heat of condensation, okay, something like that, the heat of fusion, or what we call as the latent heat. Okay, latent heat of vaporization, latent heat of condensation, latent heat of fusion, something like that, because through that we can readily compute for the latent heat and also the enthalpy of that particular substance. Enthalpy, heat of formation, or like that, okay, automatically. So you can find the heat if you know the latent heat of vaporization. That's not necessarily having the formula of thermodynamics, MCP like that, automatic. If you have that, for example, latent heat of vaporization in terms of kilojoules per mole, the standard, you have to multiply that with the number of moles, you can have that heat energy already. Okay, by cancelling the number mole in the denominator, something like that. Okay, because it is expressed in kilojoules per mole. Sometimes it's expressed in kilojoules per kilogram, something like that. And then if there's a mass of that particular substance, you have to multiply that with that mass, and then the energy will be solved. That's already your heat. Okay, you get the point? Not necessarily, taking the temperature changes. By that latent heat, the vaporization and condensation, like this, given, you can easily compute, okay, through the chemical reactions, balancing of chemical equations to the number of moles. Okay? Like that. Because this latent of vaporization, latent of condensation will be used also in the process of distillation. Something like that, huh? Vaporization and condensation will always be there. They are partnered with each other. Okay, guys? That's very clear. Okay? And that's the first topic we will be able to discuss. Okay, later we'll go one by one like this. Okay, another, also we need to discuss the phase changes after this. Okay, okay, if you like this video, you can comment down below the comment section, and you can also subscribe to my YT channel. Okay, and click the notification bell for some newest updates. I am a singer, eternal voice. Bye bye. Let's go to another topic after this. See you later for the phase change. No, not phase changes. Phase diagrams. Okay, bye bye.